Okay, I think I'll get started now. This talk is about chaos. I've been doing this a long time, writing code. It's getting worse. And I think it will continue to get worse until we get to the singularity and then we don't care anymore. Again, questions? This is the right channel for this, so same as every other speech, we can do that way. So I want to go back to the 1970s. I was writing code throughout all the 1970s, and to some degree it was a really happy time because it's quite simple. This is like the third machine I worked on. It was an IBM 1130. It has 16K of memory. We actually priced out buying another 16K of memory. It was going to be $100,000 for another 16K. But it's a really small machine, which means, by the way, everything was kind of measured in boxes of cards, boxes of computer cards. This is a box of computer cards. It has 2,000 cards in it. So a really big program was 2 or 3 boxes of cards, which is just a couple of thousand lines of instructions. So it's pretty easy to write that all by yourself. It was a simpler time. And I can actually pretty much prove this program is correct by inspecting it. And so that idea of inspecting programs and making sure they're right, and they would be right, was kind of possible back then. But the other thing is, it ran completely disconnected. It was the world. There was no external APIs, no Googles to go to, none of this other things. This was a very simple, happy place. Compare that to where we are now. Because our reality now is, well, the programs are a little bigger. There's tens of millions of lines of code in these enterprises, all of which is interacting with each other. And we can test it, but we know the testing is already flawed. You know, we have TDD to try to do it better. We have tools like Selenium Cucumber. We have acceptance testing, all these things in environments, and bring up something in the cloud to run a complete image of my whole world. And it's still flawed. And the problem is, of course, if there's a bug, it's probably your fault. Or it's because somebody's not external API has failed on you. You really don't even know. This is not a happy world. This is just basically chaos. And how do you cope with that? Well, we have some strategies. First of all, we try to get it bound into smaller pieces, back to that happy land we had in the 70s. It's really hard to get it quite that small. We use event buses. We use clouds to scale things up. We actually have now replaced this concept of acceptance testing, which is really static, against some sort of static thing in a happy world. All the APIs, external APIs work, to actually putting that same code into the running system. So the running system's constantly checking itself. We now call that monitoring. And these are the sort of things we do to sort of cope with the fact that we're really unreliable as we build this software. And we've done now something else. We're actually now designing ourselves to automatically recover when things go wrong, because we know they're going to go wrong. And we actually put some labels on that. We kind of call that chaos engineering. And the really great thing about this is executives in the companies we work for are beginning to understand the concept that we write code that has bugs. And we're never going to be able to do any better than that. So what we can do instead is be able to recover from these bugs really quickly, because they do happen. And it's beginning to be accepted. So this whole label of chaos engineering has been very powerful to get acceptance by senior management that programs are not going to be reliable. And sort of this is their definition of it. Basically, we're experimenting on a system to build confidence, et cetera, et cetera. And the champion of this, of course, is this is kind of an art form now in some places, and particularly, of course, came out from Netflix with a Chaos Monkey, which is one of the really famous little scripts in the world, really tiny little script, all the way up to Chaos Gorillas and Chaos Godzillas. A Chaos Godzilla is when basically Netflix knocks off an entire region out of Amazon. Now, it turns out they don't actually do that because Amazon doesn't like that. They kind of just logically turn it off, but they're able to recover from that sort of thing. So it's beginning to be accepted. We talk about that. Managers can understand that. What they don't understand is our world is also chaotic. Our world where we're actually developing is also in chaos because requirements are constantly changing. As well as all these complexities in getting these systems running, they don't let us do our job. They're always telling us how we're going to handle these changes. And so we say, well, how are you going to handle these changes? Well, some people will say, well, we don't need changes. I mean, some very naive people doing that, and that's basically they're liars. Or in fact, maybe they just are naive about this thing because changes are always flowing into these projects. They never really know up front exactly what they want. Or they say, what changes? We don't understand any changes. Again, very much blissful ignorance of what's really going on at our level because we're seeing all sorts of changes hitting us. Or they go into this sort of concept of we just need to keep a backlog. We're going to keep a list of these things in Jira. We're going to reorder them and meet all the time and reorder these things for you, which is basically a gigantic waste of time because you can't control chaos. It's chaos by its nature. So I suggest what the right thing is to begin to write processes that basically accommodate the fact we're going to have to live with change all the time. So again, like chaos engineering, don't fight it. We can't fix it. We'll never be able to fix it. So instead, let's see if we can figure out some architectures and processes by which we can accommodate that. So over the last couple of decades when I've been writing code, this is kind of the environment I've been having to play with. And I play with lots of ideas about how to get projects out the door in the face of this requirements uncertainty. So if you go back to sort of the beginning of this millennium, when sort of Agile sort of came around, you got to have this idea of uncertainty from one scale from being very certain all the way to being quite uncertain. And it turns out if you really know what exactly you want to build, waterfall processes actually work really well. I lived in that environment. I delivered a lot of code under Waterfall. We were pretty able to meet our schedules and like that. But it turns out when it gets a little bit uncertain, this is where Agile really hit its sweet spot. As you can give me something you're sure about, I can start on it, and I can sort of accommodate the changes as they come in, as long as it's not really radical. Because if you really have no idea what you're doing, it's a graveyard. We're going to fail. And so if I go to a client and they talk about, I'm not sure what I want to do, but you need to start a project on this. I'm like, no, I don't. I'm going to find another client, because if you have no idea what's going to be, I can never be successful if you have no idea what you want. So I would walk away from such projects when I can see them ahead of time. But then actually, as we're getting into this millennium, we're getting more and more interesting sort of problems. And I sort of, this sort of characterizes very nicely for me. This is a model from Dave Snowden called the Conway model. You see it quite a bit. He's got some really great YouTube videos. Go look at his videos about this stuff. He does have that Welsh sense of humor, so it's kind of that English and in Great Britain sort of very dry sense of humor. So he talks about problems being either simple or complicated, which are kind of much more traditional sort of problems. Complicated, whereas an expert needs to be involved. But he says there are other problems that he calls complex and chaotic. That sort of describes actually some of the problems we want to work on today. A complex problem is one where the cause and effect relationship does not exist. Yes, if this happens, I can figure out why this happened. But just because this happens again, I don't get the same result the next time. This is financial markets. This is Google advertising. This is asking questions like, can I loan you money? Will you ever pay it back? It's a fuzzy question. I can never guarantee the answer to that. So it turns out those are kind of the fuzzy problems, and unfortunately, they're the ones that make all the money these days. Having better algorithms in that space is very powerful. So I no longer think this is actually a graveyard, but it's actually the world of the fuzzy problems, the ones I could not figure out how to solve 20 years ago, but are becoming really important now, and some tools are helping us out do that. So it turns out these are two radically different spaces for solving problems. And I don't have a universal solution. I have two solutions. One in this space where it's very traditional, a set of techniques I use there to sort of handle the change. And then how do I handle the change in this sort of fuzzy world? So I want to take you through both those set of techniques that I tend to use in this space. So let's start with this. And I call this chaos development because, first of all, the chaos engineering caught on really nicely. And I'm trying to find some terminology to explain my world to the senior managers, to explain what's really going on in my development shop. How do I accommodate these changing requirements that are coming in? So there's actually a retailer in the UK, a big retailer. They have Agile in their space, and they actually have 3 different sets of processes. They have a sort of a legacy system that worries about all the ordering information for your retailer. They have all that stuff, very traditional organization, very traditional roles, Waterfall-like. Then they have sort of an Agile group that's making small changes to that on an iteration or a sprint basis. And then they have some really crazy guys off in the corner that are putting kiosks in stores, and you can touch it and order the right size and swipe your credit card, and it shows up at your front door. So they're running 3 different processes because they're solving 3 different problems. The last set of problems being, how do I get somebody to buy something when I haven't got it in stock? How can I keep you in the store and ordering with me right now? A fuzzy problem. And this becomes a reality in most of our enterprises. We're going to have a mix of these sort of things. So we need that mix of techniques. So let's talk about sort of the traditional problems, the ones that we sort of solve bank balances and things like getting orders right and handling returns. I use a lot of the standard Agile practices in this world. I think Agile is very productive. This is a case study from actually quite a few years ago now, where we looked at a very traditional application. There was the bids for this from a very traditional company. They said it was going to take 12 months. It was done in India, so it was only $28 an hour for the labor. And the overall price for the project is going to be $2 million. Well, it turns out 12 months was too long for the client, so they said, we want something else. I love desperate clients. Desperate clients try things, and this is my world I like to live in. So we said we have a solution that we can do in 8 months, and we give you 3 releases, so we get something out really quickly, so you start getting that market share back. Unfortunately, we were really expensive compared to those Indian guys. So we did have some offshore labor ourselves, but basically we had like 3 times the rate. And they wanted a fixed price bid because they wanted to pin us down to how much we're going to spend for this. Of course, I got 3 times the labor rate. I got to get the same thing accomplished, even in less time. So it turns out we made the bid for the project. We actually bid $1.1 million, half the price of the other guys, which means we were 6 times more effective than them in doing it, pulling it off, using these Agile practices. And these are practices that I had picked up over the early days of Agile, things I'd learned from my small talk days, things that Kent Beck and Ward Cunningham and Martin Fowler have taught us over the years. This stuff really does work. And so Agile is quite productive compared to that. Now, on the other hand, this is a number I got from one of the large consultancies in the U.S. He says 13%. That's the average increase of productivity for a shop moving to Agile. 13%, not 6x. I heard Jeff Sutherland talk, one of the key guys behind the whole Scrum part, talking about he's never had less than 4x in a project he's worked on. So what's happening out here? Basically, they're not kind of doing the things that we were doing there. So that's the average improvement. It's got to be better than that. Now, first of all, you got to understand that Agile is not Waterfall. If you have Waterfall processes in place and organization around Waterfall, a lot of those things are broken if you do true Agile. So the idea that you're really doing more like a manufacturing process than an engineering process. All those Gantt charts are completely useless. These milestone concepts are useless. We're doing sort of a continuous work in progress things. We want to borrow from manufacturing for that. And there's a big focus in traditional applications about starting to work on something. Trust me, I've started working on it. It'll deliver sometime. Instead, we want to focus on what we're finishing because that's the only thing that creates value. So these are big shifts in organizations culturally to sort of make Agile work. You have to make those things happen first. The other assumption is stories assume in the Agile process is that the next story is easy to play. I can play my stories in any order. The customer can feed these things to me. And of course, it turns out that's really hard to do in most cases. But that's kind of what the Agile stuff was. The first story is really easy because it's greenfield. But of course, every story you play after that's a change. And so if you haven't got your code easy to change, this next story is really hard. And you get to story 100 and story 200, and all of a sudden you're rewriting lots of stuff, you slow down enormously. Unless you focus on easy to change. So this particular style of programming that Agile talks about was originally developed in Smalltalk. So Kent Beck and Ward Cunningham and those sort of guys came out of a Smalltalk organization. And they had a very particular style of writing code. And unfortunately, when they told us about Agile, they forgot to tell us, oh, by the way, there's a particular style of programming you want to follow in order to make this code easy to change. So let's talk about some of those factors. This is what one of my mentors early in this said back to 1988. He says, object-oriented programming is only good for programs that change. In other words, the focus is always around the change. So, example of this, going back to that same application. The old application was in Java, Oracle, and web front end. The new application was in Java, Oracle, and a web front end. Same technology stack. The legacy system had 72 Java classes in it. When we finished remodeling the system and shipping it, we had 1,400. This is a different style of programming. This is the Smalltalk style. And let's talk a little bit about what that style looks like. It is a little strange, but it's certainly not magic. In fact, it's talked about quite a bit. This was my original introduction to it. This is a book by Kent Beck, Smalltalk Best Practice Patterns. You may be familiar with the rewrite of that book, which was done in Java called refactoring. So Martin's book is basically a rewriting of that thing that Kent Beck wrote in Smalltalk. And of course, now Martin has published a version of this in Java, the original. It's been in Ruby, and the most recent version came out before Christmas is in JavaScript. And then you have books like this from Sandy Metz talking about this style of programming. It's a different style of programming. So it's not magic. And the idea behind this is kind of captured with a concept of Agile called simple design, which kind of says, you know, your code can work. The code needs to communicate. It needs to scream out exactly what it's doing without comments. Comments are a sign your code's not clear. Fix your code. We get rid of all the duplicate code following the solid principles. And then we want to get rid of everything extra. Keep it as small as possible. It still works. Unfortunately, a lot of time, of course, making it simple like this is not easy. And I refer you to a Rich Hickey talk that talks about easy is not the same as simple. You know, finding the right simple solution, it can be difficult. But a lot of organizations, you know, get it works and then it stops. And of course, if you keep doing this, then you wind up building up a lot of technical debt. And the technical debt, of course, makes you go slower in the future and you basically falls apart. You've got to keep working through all these things. There was a really great talk at 3 o'clock of, let's see, his name was Valdek. I think it was Valdek, talking about his pyramid. He was talking about these things, making sure your code is absolutely gorgeous before you claim it's done. Otherwise, you create this problem. So one of the things we also do is we actually separate the business model away from the user interface and away from the persistence. So I was taught that you design your business logic, because the business logic describes the business. That's a relatively stable thing once you get it right. Don't worry about what the user interface is. That's going to change a lot over time compared to the business change. Don't worry about persistence. We'll have new ways of doing that, new databases. We'll put things in JSON. We'll do all sorts of crazy things. But you want to separate those two and make sure you keep these interfaces very clean. So unlike, say, something like Visual Basic back in the day, they said, no, put the business logic behind the user interface. That made you really quick to start with, but then, of course, your program would die over time because it gets too complicated. Or you go into the Rails thinking, which says, oh, yes, let's put all our code behind the database because we're model. That's called they think it's a model. No, it's not really the business model. It's tied to the database structure. And when you start tweaking the database structure, all the code breaks again. You got to separate yourself from those environments. So that's one of the things you do to sort of get that speed. So typically in this code in this style, if you look at sort of the average method size, and I sort of ask audiences over time how big this is, and they say, well, 25 lines of code would be reasonable, or 1 page, or maybe 10 lines of code. But in that nationwide project, which we did well over a decade ago, our average size was 2.3 lines per method in Java. This is not the new Java. This is like Java 1.4. And basically, if you're doing this kind of in Smalltalk, you would actually probably have something even smaller, like 1.1. When I'm using languages like Kotlin now, I'm getting down to the 1.3, 1.4 sort of size for average method sizes using these techniques. So it's a different style of programming. We also make sure we don't violate encapsulation. That's one of the ways that you leak out information. So we don't like public variables. We get rid of all those guys. We also get rid of all the getters and setters. Some people think a getter and setter is okay because it's a method. Well, I'm sorry, you're giving away your data again. The bad things happen when that happens. So you don't like those either. We don't like classes in an ER or OR. A class that is an ER or OR is always like it's a manager class, it's a director, it's a calculator. It must be grabbing data from somebody else. It's a violation of encapsulation. Push the problem to where the data is. Hide the data from that. A different style of programming. And the concept of a data object, that's a complete oxymoron. It's data, and it gives all the data to anybody who asks for it. It's not a real object. It's not behaving along that style that came from Smalltalk. And finally, if you have this sort of string of A.B.C.D, which you see a lot of, it's probably because B and C and D are instance variables or getters. And basically, you're sitting there over here, and you understand the entire chain of objects all the way through your system. That's fragile. I can't change that without impacting lots of people. So you got to get rid of these sort of things in your code and make it easy to change. That's where you get the productivity. We also throw some statements out. There's statements in the language we don't want. Case statements, a source of lots and lots of bugs associated with all the various cases you can have. So in the core model, we don't have those. We don't like else statements. We write entire systems with a single else statement. Because, of course, the else statements cause different paths through the logic. The more paths you have, the more complicated it gets. The more bugs you have, we kill those off as well. We don't really like if statements unless they're the very first statement. In other words, they're guarding the rest of the code from something else. If you're in Kotlin, you can put a require statement in there, something that sort of catches all those things right up front, making sure the rest of the code is perfectly good. So the if statements are a little suspicious, especially if they're deep into the method. And even enums, because what's an enum? It's something you're going to have to run a case statement against. Well, I don't want the case statement. And finally, of course, you have other things that are like that. So we have some data types we don't like. So yeah, they're in the language, but we don't want to use them. They make bad code. Examples of Booleans. What's it good for a Boolean? When you pass a Boolean parameter in, you got to have an if statement. Well, don't like if statements. Get rid of the Booleans. Maps. Anytime you have a map, you're like, here's a string and here's a double. And they're not naturally friends. There's something magic about that relationship you're trying to tell me about. Model it. Pull it out. Make a class out of it. Naked numbers. Of course, naked numbers are really dangerous because they have different meanings. See Mars shuttles about that. So we use quantity patterns. Strings, you can misspell the string, so we hate strings in our model because they can be misspelled as well. Get some types in there instead. So a lot of stuff we throw out of the language in order to make it easy to change. The second thing is we want to make sure the team has a delivery focus. It's all about finishing things and moving forward. It's about rewarding success for getting things done. Not working on them, getting them done. So we only count what's done. When you come in and say you're 90% done, you're not done. And you want to pass that attitude throughout the team. We focus on finishing the old stuff before we start anything new. Oh, look at this really cool new thing. Yeah, but let's finish the old stuff first. Let's get rid of that. Of course, bugs then. Of course, you have a bug in something. That means something's broken. Let's get it fixed and make sure it's working again so that we can sort of close and finish that story off. So we focus very much on bugs as the highest priority work every day. Get rid of those bugs. And in our stand-up meetings, I'll focus about what did you finish yesterday? Don't tell me what you're still working on. I want to know what you finished yesterday. If you've broken your stories into tasks, you finish something every day. Otherwise, we've had some sort of process breakdown. Let's go figure that out. So, write code that changes easily, delivery focus. The next is, you want to think about enhancing the productivity of the team. And when I think about productivity for the team, I've looked at, over the years about how fast tools can improve you. Some tools help you a little bit. Some process changes may help you. You may have some management techniques and stuff like that may help you. But nothing really compares to raising the skills of the people in the room. Everybody in the room has some different skills. How do you transfer those skills amongst the various people? I love pair programming for that. I have pretty much easy. If I give a team for 6 months, I can probably double the productivity of those programmers. They'll be twice as fast and twice as productive by just rotating the pairs around and picking up the skills of everybody else in the room. That dwarfs any best tool thing I can do or any new process I can put in place. I focus on raising the skills of the developers. The fourth thing is making sure the fears are gone. Fears are rampant and they sneak in very subtle ways. And fear is what paralyzes us from innovating processes. So we've got to kill the fears off. One is it does cause things to fail, so make sure there's cost associated with failure. So I can't do that because it might not work and it's going to cost us a lot of money. How do you sort of cramp that fear out? I might get not promoted. I may in fact not get promoted. I may get fired if I do something. I worked in an organization in London where we bought a company, and the company was basically, everybody's afraid of doing something because people have been fired for making mistakes. Fired. So why should I ever try an idea? I don't want to innovate. Why should I innovate? Of course, estimates, we all know how much fun they are, because as soon as I make an estimate, somebody's going to say, okay, well, why didn't you have that estimate correct? What's wrong with you? Can't you make that? You finished early? I'm upset about that too. What's wrong with your estimates? A fear, all because you sort of ask a question about how much, and we're engineers. We're trained to answer questions like that because they have answers. Don't answer those questions. Of course, we're not doing it the right way because there must be a right way to do it. That sort of discourages innovation again. And failure is an option, especially fast failure. So I love organizations and processes that allow us to fail, because failing fast actually is quite productive. We learn a lot from that process, as long as we discover the failure very quickly. So TDD is all about fast failure. Pair programming, all about fast failure. Working the bugs is the highest priority, means as soon as I make a bug, I'm going to fix it as soon as I see it. Fast failure again. So focus on killing off the fears by sort of saying failure is okay. I don't mind trying things. We expect the failures. We're innovating. And how do you handle the in-project changes as they come in? So again, going back to the nationwide, we had a schedule that says we could deliver across 3 months, and the alternative proposal from a large consultancy was 12 months for alternative. Well, it turns out, of course, change happened. Of course, we knew that would happen, but change did happen. In fact, what they did is they, oops, go backwards. Well, they came in at the beginning of the third release, and they changed 80% of the content of that last release. 80% of it. Now, if you were the firm at the bottom, of course, an 80% change at that point in your timeline means it's now going to be an 18-month schedule. Thank you very much, because we've done a lot of work. Or let's talk about a new release too. In the case of us, we had done nothing to worry about those future stories. We looked at what they wanted to do. We sort of took out what they didn't want anymore. We said, oh, that looks about the same. And we were perfectly happy with it. No schedule change. We delivered on time with a new functionality. That's a process that allows change to happen. And it was very effective in that. All right, so that's kind of, in the Agile world, these are techniques I use to sort of handle those traditional problems, the ones we wrestle with a lot and have wrestled with a lot over time. They're still with us. And so when I get a problem like that, these are the techniques I use. I'm currently working in Oslo for the government there. We rebuilding a very important healthcare system. We're using these techniques because healthcare and that is a very known problem. We have exactly laws we have to follow about how we pay and when we pay and how much we pay. All that stuff's all laid out. We can have great stories around that stuff. These are the techniques we're using. But you get to fuzzy problems, it's a whole new world. So in fuzzy problems, I have a different set of techniques I like to use. First of all, you have to really understand that in a fuzzy world, there is no stone tablets describing your requirements. It's by its nature fuzzy. Nobody knows what the right answer is. They can't give you directions about that. And so you have to shift your focus from getting these requirements and managing around requirements and managing around stories into how fast can I try new ideas out. Competitive advantage for fuzzy problems comes from being able to try ideas out very aggressively. And that's what you need to sort of organize around. How fast can I try something out? And when it doesn't work, how fast can I take it back off? And if I have a fast process for this, I'm very brave and I can try lots of things. This was a mantra when we did this in London at one company I worked for. We called it experimentation drives innovation. This was our catchphrase. And I love this because experimentation implies we will try things and they will fail. Expect it to happen. And when people got upset that something happened like that and we tried something and failed and some product owner came to us and said, wow, if you had some more meetings about this, we would be able to not have these problems. And I said to him, first of all, I told him to shut up. And if he didn't want to listen to me, we'd go see the managing director and he would tell him to shut up. Instead, we want to figure out how to go faster so we find these problems quicker. We're all about going faster when this happens, not how much more process we're going to put in place. And by the way, a lot of managers will react by putting more process in place. That slows you down. That's against the rules for fuzzy programs. So we rethink our interaction in this world between us and the customer. I drew this triangle many years ago with a colleague from ThoughtWorks. We sort of characterize requirements in this sort of tier. Stories are about all we know about. Stories are very much the description of a problem that has some business value. We as programmers break these into tasks. And these stories are part of a feature or an epic, depending on what name you want to apply to that, which applies to some overall project. And at the peak of the pyramid, it's a business initiative, something the business was really trying to accomplish. This nice hierarchy is very powerful in Agile. And of course, most of the processes talk about stories and how stories, and we count them and we measure them, we estimate them, and everything is around stories. But you're in the fuzzy world, this is not where you can be because stories are missing. Stories, we don't know what a story can be. Instead, the role of the customer becomes telling us about the business itself. Train us in what the business is about. Tell us what critical success factors mean. Is it more logins? Is it more money? Is it more clicks? Is it longer page retention time? Tell us what the metric is. And then, frankly, get out of my way. We solve problems. That's what we're good at. That's the problem we need to solve. So educate us in the problem and get out of our way. That makes us faster. We want to exploit the nature of fuzzy problem. Fuzzy problems are really unique in many ways because of these sort of factors. You need to exploit them. First of all, it's really rare to have transactions in a fuzzy problem. Transactions are very much a traditional thing. You decide to buy something, that's very traditional. Deciding what to buy and what to recommend, that's the fuzzy part. But when we move over to actually trying to buy something, we push it over the traditional systems. So transactions are actually quite rare in fuzzy problems. The other thing is, eventual consistency is actually okay because we're making fuzzy questions. So the fact my databases, maybe a little database may be out of sync for a day or two is not a problem in a fuzzy problem. We need to exploit that. Oh, I have to have perfectly consistent data. Yes, for traditional true, not true for the fuzzy problems. Take advantage of that. Well, some parts of the system can fail in the fuzzy nature and the system can still run because it's fuzzy. So maybe I'm not making all the checks about I should for it before I loan you money. But it was a fuzzy question anyway. So if part of my checks are down today, I can still make a recommendation. It'll be better with all the other services helping out, but it's a fuzzy question. So these systems can be very robust and keep working in the fact of failure. Take advantage of that as well. So it turns out microservices, and I'm talking about really small microservices, not services that have been labeled as microservices, but small microservices. The small microservices are really good for this sort of thing because of some things we try. And one of the things we want to do in this environment, of course, is write these really small things. We want them very small. The rule of thumb has been in the past that if it takes more than one developer to write, implement, and maintain the service, it's now not a microservice. It's bigger. I've had people come up and say, we got a team of 6, we're going to work on this microservice the next 3 months. I'm like, that's not a microservice. This service is a perfectly good thing to do. In fact, for traditional problems, the services are very powerful, but it's not a microservice. We want them loosely coupled. And the reason to do is we want to experiment. And the more tightly coupled these services are, the harder experiments are to make. So we're all about loosely coupling these services in order to make this happen. We want to be able to allow multiple versions to run at the same time. We want to be able to run our experiment beside our production system. So we want to be able to drop an experiment in and try it out. If we like it, we'll turn the other guy off. If we don't like it, we're going to turn it back off. We got to allow the system to run these things in parallel, very much like the internet does. Services are also responsible for figuring out they do something wrong. So if my service wakes up, looks for a Google report to judge how well I did yesterday, and it can't find it, there's nothing wrong with me. It's Google's fault. But I need to raise my little hand and make a lot of noise saying I can't do my job. So these systems have to be very self-diagnosing in order to make it themselves very fast. And basically, we stole this idea directly from Google. If you do something interesting, publish it so that other people can sort of take advantage of this information and maybe try their experiment. So Google did this really well. They published everything, did something interesting. They published it on an event bus, even though nobody knew what they were going to do with it. And then somebody has a little crazy idea. He looks at the event bus. Well, everything he needs is right there. I don't have to negotiate with you and you and you to get an API put in place to try my experiment. That means people got to sign this off. We got to prioritize it. We're going to have discussions. We've got meetings. I don't want to do that. I'm trying to be fast. Excuse me. And finally, the whole concept of application in this world doesn't exist. It's basically some functionality. It keeps growing and growing, sort of like a moss or some other disgusting things. But it's very much sort of a very live, living system at that point. So one of the things I like to sort of judge in terms of microservices is I sort of count how many services you have and how big they are. So I call this little line down there the Rails and Java zone because it's kind of this big monolith we have. When services came about in the early part of this millennium, and Credit Suisse was one of the leaders in this space, we took that multi-hundreds of millions of lines of code and turned it into 50 to 100,000 line of code pieces because we knew how to manage those. And so we created this concept of service-oriented architectures. And this was kind of its sweet spot. But the microservices stuff is still service-based architecture, still the same philosophy, but it kind of lives in this world. They're much, much more numerous and much, much, much smaller. Again, because they're highly decoupled and we're experimenting. So for example, this is when I worked in India on a large project, 1 million lines of code. At one point, it was the largest Sun-certified Java application in the world. This is something you do not want to be. So my life is too short. I won't do that again. I ran a workshop earlier this week on microservices. We developed, basically an offer engine. I'll show you some examples of that. We write about, in the long version of this, we write maybe 10 or 15 services. They're less than 30 or 40 lines of code each. When I worked in London, over 300 services, basically doing Google advertising, internet sales, that sort of thing. Again, fuzzy world. We had lots of services, no more than 100 lines of code each. That's Netflix. This is where the Netflix lives. Chaos engineering is all about small changes. They're trying things all the time. Netflix experiments on you. They literally go to the marketing guy, says, give me 100,000 users, and they give them 100,000 users, and they switch you over to the new software. And when your software breaks, you think it's your internet provider, or you think you dropped a connection, or you think your browser has a problem. No, Netflix crashed. Guess what? When you come back in, you get the old code again. They're not going to tell you that, by the way. Why would they tell you that? You think it's their problem. No. It wasn't your internet provider's problem. It was their experiment on you. That's a different world. They're doing fuzzy world stuff. And they're running very, very small. I'm a big fan especially for the fuzzy problems, using asynchronous services. By asynchronous, I basically mean using event buses. Sometimes called actors, all those sorts of things like that. So you have this high-speed event bus and a service sitting there saying, ask a question. Now, the question may not have an answer. Maybe nobody's even listening to my question. I have to worry about that when I design the code. The question might be, hey, should I loan you money? So I ask a question. Hopefully somebody's listening. In this example, I got 2 people that are listening for that. The blue guy is actually looking at your bank account. Yes, it's positive. That's very good. And it looks like the regular deposits probably means you have a job. Yeah, I kind of think you're probably a good idea to loan money to. The green guys may be running off to a service bureau and asking them the question. And these guys will express their opinions back about whether I should loan you money. These guys will collect their opinions and make a decision. Now, the nice thing about this system is, let's say I have a new idea. Maybe I want to figure out what university you went to because I look up your LinkedIn or something else you've been doing like that. And I find that you went to a major university. And I have a theory that says you went to a major university, you're probably a responsible person. So I'm going to put that into the algorithm. I can add that right here. I don't have to tell the yellow guy about it. I don't have to tell the blue guy about it. I don't have to tell the green guy about it. He's just now participating, experimenting. If I have a better idea for a blue guy, I can write blue guy version 2 and bring him up in parallel to version 1. And they're running perfectly happy beside each other. If I like the new blue guy's answer, I'll turn the old guy off. Again, nobody else has to know about that. If the green guy goes down, I'm still giving answers. No, not as high a quality answer, but the system's not broken. Everything hasn't stopped. Now, these sort of architectures are a little harder to think about, a little harder to design because it's strange and new for us. But they're very powerful for these fuzzy problems. So again, variation is easy. Graceful degradation is built into the system. A great solution for fuzzy problems. This is an example we actually went through in the workshop earlier this week. We talked about a legacy system as a car rental, and we want to put some advertising on the page to convince you want to buy something or even buy something more. The business guys call this share of wallet. They want more of your money now that you're already coming to see me. So we do that by building ourselves an event bus. We hook into the legacy system to generate some events on the event bus. We bring up a couple of services that have ideas about what they could offer you. One is going to run at the brand level. The company level is going to do that one. But each individual rental location has their own problems. And so they have their own things they want to handle out. And they will compete for the attention of the user. So I can get that running pretty quickly. In fact, we had that running in the first 3 hours. And then we enhanced it. We said it would be nice, actually, to know if you're a frequent renter. Or it may be nice to know from a segmentation what type of rentals you've had in the past. If you rent from Monday to Thursday, chances are it's being paid for you by your company. So a discount is not going to incent you in it. It's not your money. But how about some points? Or how about a bigger car? So let's change the incentives based upon that. The nice thing about this system is I can deploy the system very quickly and begin my experiments. And I can keep trying different ideas all the time and make it a better and better system. When I worked in California, we developed a system like this for one of the large hotel chains. We charged them $6 million to develop the system. It wasn't that hard. They made $40 million additional revenue in the first 6 months alone. So they were absolutely delighted. And we were very happy too. Fuzzy problems are extremely profitable. That's where you make the real money, is solving those sort of problems. Microservices works well in this environment. I don't believe in Conway's law, very famous law, because I've broken it so many times. But there's kind of reverse Conway's law that I do kind of subscribe to. And that basically says you got to organize yourself around your architecture. Whatever your architecture is should drive your teamed organization. If you're doing microservices, you need a very small, focused team that understands the business problem they're trying to solve and are trading ideas amongst themselves. So if you try to do this with a very traditional organization with business analysts and testing organizations and designers all separate, don't bother with it. You're not going to solve the fuzzy problem very well. You got to reorganize yourself around the fuzzy problems. So this will drive you to do it correctly. So if you think about the Agile practices and you compare to what we do with fuzzy, again, I've listed sort of my favorite Agile practices and roles here. If you're working in fuzzy problems, those sort of practices go away because we're constantly experimenting. There's no concept of being able to do story narratives and retrospectives and talk about estimates because they're pretty much useless. We're all about experimenting and looking at what the business returns are from our experiments. We're expecting failures. In particular, we want to make sure there is no concept of blame. When somebody starts to blame people for something, that's when I stand up and I stomp down on them. We will not have blame. We're trying things. Of course, we're working now in cycles that take hours, not days or weeks or months, and so the concept of iterations kind of goes away. And since everybody's kind of sitting together anyway, if you need help, you ask for it. So we don't require pair programming. I do that a lot in my traditional things because I want the skills transfer. In this area, not required because we're working so well and tight as a team. Finally, all this testing and stuff kind of goes away because our traditional processes, first of all, these microservices are really tiny. Why would I write a unit test for something that's 13 lines of code? You can't write 13 lines of code to get it right, find a new job because you're not a programmer. I don't need a unit test for that. If I want to change it, I just rewrite it. It's only 13 lines of code. I'm sorry, it was written in Visual Basic. Okay, I'm going to write my version in Ruby. They're easy to rewrite. So a lot of the traditional needs for these testing goes away. And we're building a system itself that's self-monitoring. It's watching what's happening. It's measuring the business value. And so I can deploy very aggressively into that system and watch what the experiments do. And so I don't need this, quote, acceptance test, because I don't know what the right answer is. What is the right answer to loaning you money? I don't know how to write an acceptance test for that. Finally, continuous integration goes away because we're actually continuously deploying. We're pushing that code out aggressively. In fact, this comes from 2006, sort of see what's going on here. This is a project I worked on for a company in London. I'm the Fred there, not the George. George was a different guy. George was actually the team tech lead. This is a Ruby project. It was my first Ruby project. Dave was a team lead. I was one of the developers on the team because I wanted to do Ruby, and it was kind of fun. George, of course, wrote code as well. So those were some of our formal titles. We had a business analyst. Jeremy was in there. His job was doing the business analyst. We didn't really have any testers because we thought we'd sort of test as we went from people we had. Now, this is the official titles. Very much traditional thinking about titles. But what really went on is we're solving a fuzzy problem. We're trying to figure out what phone plan makes sense for you in Britain. And there's over 1 million choices. So it turns out, Dave, the project manager, also ran the test as well as the customer. He was seeing what we did and see if it was kind of meeting his requirements. I'm in there because I'm an experienced manager, done this many, many, many years. So I was kind of also doing the manager, doing a lot of talking, particularly to the client. I also had design skills for how to do things like that, so I was in there. Paul, who was actually really excellent at this stuff. Paul could read a journal article and learn how to write the code from it. That's an amazing talent. I can't do that. I get bored. I was also a UI designer. One of the things I've done in the past, when you're old, you get through lots of things. So I did UI design along with the customer. And in fact, as a business analyst, we understood what business we're trying to solve. We're trying to sell phone plans. It's not rocket science. It's pretty easy to understand that. In fact, we were so good at that, Jeremy rolled himself off the project. I don't need a business analyst. He rolled himself off the project. That's full stack developing. That's what you want to have, is basically a team that is undifferentiated relative to its skills. Everybody's using their skills that they need to every time. This is the nature of a fuzzy problem. Yes, we may have titles. Ignore them when you do fuzzy problems. In terms of roles, because it's fuzzy, these roles go away. You really just need the customer to tell you what you need, and you move on from there. So this is what we did when we were in London. We were very aggressive in how we did things. We had 53 developers. We deployed lots of times. This actually comes out to, I didn't put it at the bottom, we were deploying new code in production every 3.5 minutes. That's how fast we were experimenting. We had 50 employees one time. We made 50 million pounds that year. That's rarefied atmosphere. So, in summary of this, if you're in the Agile world, these sort of traditional stuff makes sense. Stories, retrospectives, specialists, TDD, acceptance tests, migration scripts. If you're in the fuzzy world, though, it's a different world. Work differently. It's about ideas. Find the ideas. Try them out. Full stack developers, because they're fast. They can do everything. Systems that fail fast. MicroServices. Event-based architectures. Continuous deployment. This is how you get into that space. So, two different approaches to making chaos development work. Chaos development, again, being that we are getting constant change in requirements. Turns out, in traditional world, I have techniques for that I stole from the small talk guys that Agile came from. And in the microservices world, we have a whole different world of experimentation that's so different than the traditional world. Most of my clients have both worlds. We make sure we work differently in those two worlds. That wraps up the presentation and talks about chaos development. I have a couple of minutes here. We'll see if I have any questions. I did, by the way, turn off my internet access during this process because it's embarrassing sometimes what comes up. So let's take a chance to turn it back on. And yes, got the connection. And let's bring up Slido. Unfortunately, it's this way on my screen. I've introduced a lot of restrictions on code for good reasons, which leads to smaller but plentiful units. How do you come up with the names for all of them? Basically, we're modeling the business. And a lot of these very small units actually are implementing various design patterns. So you'll see the word strategy stuff on things, or state stuff on things, or observers and the like. So usually it's not a very hard problem. But we do like to use domain names where possible. So, for example, we had like 5 different types of agents we could sell things to. So we had 5 classes that were named after the types of agents we had. So we never really found that much problem in sort of the naming these things. The other thing of the other nature of this particular problem is we wound up with 1,400 classes. But they're actually grouped into basically 25 Java packages. And the packages themselves had very few classes that were public. Most of these classes were internal into those things. You don't expose the states and strategies necessary to the outside world. You sort of hide that stuff. So we could probably practice encapsulation at 2 levels, within the classes themselves, but also within the packages. And if Java had a 3rd level, I'd use that as well. I love the concept of namespaces where I can build all the levels of encapsulation I want to. And by the way, service-oriented architectures give me nice boundaries as well to draw things around that. So we're using traditional stuff, building code in this style, and wrapping services around them to sort of, again, encapsulate them at another level. I'm a huge fan of that. So what do I do to make it go away? Nope, that didn't do it. Oh, yeah, it did. Could you show us some code with all these restrictions? Yes, but I would say since we're out of time, go to my GitHub account. It's Fred George, not hard to find. And I have a blackjack game that's done in Ruby with no else statements. You think about blackjack, everything can go wrong, all the rules and how you double down. It's all in there, and there's not a single else statement. A lot of good design patterns. So you want to see an example of that, go look at that Ruby library. Ooh, we got some more questions. And I got to say, we're kind of out of official time, so I should probably let it wrap up at that. I'll be at the party tonight. I'll hang around here afterwards so we can watch some movies. You know, I think Joker seems to be a good movie for us tonight. After some of the things we heard this morning, it's really scary, so maybe Joker would actually be a humorous show for us. But that's out there as well. So thank you for your attention. Thank you for hanging around. Again, find me, ask me questions. I love talking about this stuff. Thank you.